All right. Well, I guess since there's two of you, we can at least get started. Any questions you guys want to go over specifically before I just go through some basic stuff? And basically, this is your chance to ask questions on any of the homework assignments or mini projects or whatever that you're struggling with. Nothing? Nobody's got any questions?
Sorry, Dr. McBride. I was talking and I was on mute. Um, I wanted to get some insight or some input on this is 3.4. So I started and I'm working in Excel on the problems.
Okay.
And I started putting in the figures to work out the problems, and I guess I was running into issues with part B. So I wanted just if you could go over that problem and offer any tips, that'd be good.
So a part B where they want you to divide the range and then come up with that whole thing?
Mm-hmm.
Okay. So where is it? Oh. See if that fixes it. So here is the data set. And they tell you to take the range and divide by 7. Well, if we sit here and just do equals range. Not do range? No, I guess they don't do range, so you have to do max and min, I guess, or just sort them. That might be the easiest. It's just sort your data from smallest to biggest. And then, of course, the range is simply going to equal this thing minus this thing. Top minus bottom, right? So we get a range of 0.33, which I think it even told us that. No, they just said divide it by 7, which gets you an interval of almost 0.5, right? So if you then say, okay, equals this divided by 7, and that's where they say you round up and you get basically 0.05, and then they tell you to start at 0.05. And then here are the bins, right? Here are basically your classes. So it goes from 0.705, and then you add 0.05 to it, and it becomes 0.755, and then you add 0.05 to it, and it goes to, think about them as percentages, right? So you're adding 5%, right? So this is 70.5%, 75.5%, then 80.5, 85.5, 90.5, 95.5, 100.5%, right? And then 105.5%. So it's kind of the easiest way for you to not mess up the math, so to speak. And then it's really just a matter of counting how many you have. I mean, with Excel, I think unless you have a super large set of data, the easiest thing is just do it by hand. And you can see that if I'm going from 0.705 to 0.755, that's just these two. And then 0.755 to 805, well, that's 7.6 all the way up to 0.79. So that's those 4, right? Then the next one, 80.5 to 85.5. Well, here's 81 all the way through 85. And you can see down here, there's 8 of them, right? You just keep doing that until you get your frequencies. And then your relative frequencies are simply, you can just say it equals this divided by 25, because that's how many you have, right? If you add them all, you can see you have 25. So that's how you can compute all these, is just take this and divide by 25, and round to 2 decimal places. So that should take care of constructing a frequency histogram. You're now basically constructing a histogram from these values.
Right. Okay. I think I don't know what threw me. I think I was thrown off by the class interval width for whatever reason.
Yeah, well, it's not described easily. So there's no shame in being a little confused with that whole class interval width, because it is a little confusing. And of course, the numbers are not easy because they want you to start with 0.705.
Mm-hmm.
So, if they had taken off the 5 and just start with 0.7, I think everybody could have figured it out a lot easier and gone, okay, 0.75, blah, 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 keep going on and on.
Mm-hmm.
It's that 705 thing that screws people up, because then when they have to add 0.05, then their heads start to explode. It's like, crap, where does the 5 go, right? And you got to realize that 0.05 means that the 5 goes in the second spot. So 0.705 to 0.755, it sticks there in that little center spot. So yeah, it's not the most easy to understand set of numbers, that's for sure. And then I think you can do a histogram fairly easily.
Pretty easily in Excel.
Yeah, exactly.
Okay, thank you for that.
Yeah, sure. Yeah, and then I guess you got to futz around with it to get the bins right or something. I don't know. I don't do a lot of work. I don't do a lot of graph work in Excel, so I'm not.
Yeah, I know I'm just gonna pull the frequencies.
Yeah.
From that and then create the chart that way, because it can get a little finicky in Excel if not.
Yeah, totally. I can never remember. I know there's a simple way of just highlighting your data, but that doesn't seem to work. So I don't know. That's
why I use a Mac. I use a Mac because I can cut and paste so easily. Doesn't matter what I'm dealing with. I can take your picture that's on the side of the screen right now, just cut it and put it where I want it. So that's why I use the Mac.
Yeah, well, I'm talking about trying to get the right stuff out of this thing. Like I would just do the histogram from SAS, right? I mean, it works fine. You do the frequency and run that, and there's your stuff, right? But the problem here is what it's doing is it's looking at the frequency data, and that's not what you want. You want to look at the fluoride data, and then even that's not going to be what you want, but it's better, right? You can put appearance, change your bins 7, and that's basically what they were asking for. But I mean, if you really want it to look nice, the only way to make this look nice is to do the code, right? Where all you have to do is click edit, and then you can see it created a copy, right? So this was my histogram code. You can see here is an exact copy of it, and they just created a whole new tab up here, and they called it program 1. And this is now the code that it used to create your histogram. Well, if you then go to our SAS how-to guide, and you go to week 2, and here's a really pretty way to make your histogram. Just highlight it. Do Control-C. Go back here. And Control-V. And all you have to do is make sure that your data is in the right place, right? So if you click back here, you can see that your data was in work.import right here. So you just need to tell it that your data that you're working on is in work.import. And if you run this, It gives you a bunch of analyses that you don't need. And then it gives you the picture perfect histogram. And then it gives you one for relative frequency as well. So there's your frequency and there's your relative frequency. So you can see frequency is numbers. So right, remember this was that one that we saw had a frequency of 8, and that one right here, frequency of 8. So we see 248 4421. And we go here, 248 4421, right? You can see that it matches perfectly. And then relative frequencies, these are percentages, right? So this one's like, 8%, 16%, so on and so forth. 8%, 16%, 32, and so on and so forth. So you'll notice that the shapes are exactly the same, which of course they should be. It looks like it's flipping us off. But the only difference is the scale changes. So that's one thing to kind of learn about histograms is when you do a histogram, you're getting relative frequency because the height of each bar is relative to the heights of all the others. So whether your scale is pure frequency or relative frequency, i.e. percentages, it's not going to change the shape of the graph. It's going to be the exact same thing either way. So when you do, either one, the only thing that's going to change is literally just the vertical scale is going to go from a count frequency, right, to a relative frequency, which is a percent, and that's it. So I don't know. I think that's easy enough for you guys to do to get, the best result that way rather than any other way. And quite frankly, there are probably going to be some times in other classes, 8, 10 in particular, and then maybe even with your dissertation where you're going to have to do some basic coding, right? You're going to have to actually manipulate the code yourself. So it's good to understand just the basics of how it's done. Because if you can get a nice set of code, or, like let's say you're trying to figure out how to do something and you go online and you find an example, a code example. It says, here's the code that you need to do whatever you're trying to do. You copy that code and you put it into SAS. It's not going to work because the code example you get might not have the data listed in the right place. And it might be dealing with a different variable, right? So really, those are the only two things you have to change to make your code do the same thing. In the case of this, build a pretty histogram for a different set of data, right? So like later on down the road, you want to make a really nice histogram for some data that you have in your dissertation. Well, all you have to do is you have to load that data, right? You bring it across, and you click a little run and then it puts it somewhere. And then all you can do is come in here and change it to wherever that data is, right? So maybe it's now in import 1 or 2 or 3 or whatever. And then you want to run it on whatever variable you want to run it on from your data set. You just change that variable name there and you change that variable name there. And blammo, you run it and you get your histogram for that. Now, obviously, you might have changed this stuff, right? Because if your data values don't start at 0.705 and end at 1.05, you could have a different starting, a different ending, and then you could go up by a different amount, right? So just by looking at this code, you can kind of figure out what the hell it's doing, and then you can manipulate it really easily. You could copy this code and you could paste it into another new program document. You could change up these numbers and then therefore change the starting and ending point of your histogram. You can change the widths of the classes by messing with the by part, right? You can change the axis, right? The vertical axis goes from 0 to 9 or 0 to 35 by 5. You can change all of that, right? If you want it to be bigger or smaller, or go by bigger steps and so on and so forth. So once you start looking at this code, you can see that it's fairly straightforward. It's fairly easy to work with. And all you have to do is change it around for where your data is and what variable you're working on. Okay, so does that fix 3.4b for you? Or I should say, what else? What's next? What do we need some help with?
Yes, to answer your question, that helped me.
Question.
Thank you.
I have a question.
Go ahead, Vladimir.
Okay, so it's not specific to the homework, but it's basically more in terms of the deadlines. So I know that this homework is due this Sunday. So then next week we're starting week 3. So the homework for week 3 would be due next Sunday. But then about the project.
It's also due next Sunday. Everything is always due the end of the week. So everything is due Sunday at midnight. The only thing that is due on a day other than Sunday is the article critique, right? Your research article critique, where you go out and you find a research article that discusses some statistics and presents some statistics. You're supposed to write up your critique, and you need to post that critique to the discussion board, the research critique discussion board, and that needs to be done no later than Thursday at midnight of that week, which is December 2nd is that Thursday. And the reason why we need that one done by Thursday is because the second part of that assignment is everybody has to go in and read somebody's critique and then comment on it. Well, if you post those up by Sunday, nobody will have time to read them and comment. So that's why those have to be posted by Thursday, so everybody has time to read them and comment on them. Everything else in this class is always due on Sundays. So the homeworks, the mini project, the final project, all due on Sundays.
Okay, very good. Thank you.
Yep.
Okay, I think I missed what you just said though, Dr. McBride.
So he wanted to know when stuff was due, and I said everything is always due Sunday at midnight except for the critique of a research article. That's the only assignment you guys have that's not due on a Sunday. That one's due on a Thursday, so that people have a chance to read your critique and respond to your critique, because that's part of the assignment. So that's why that one has to be turned in early, so everybody has time to read them and respond to them by the end of the week. So the critiquing of the research article is due Thursday, December 2nd. Everything else is always due midnight Eastern time on Sunday.
Thank you.
Yep. What else?
So I have a question. I plotted my histogram, but I'm now looking at your code, which is a little bit different than mine. Mine is SGplot, whereas yours is univariate. Because of that, my endpoints, like even though it says start at point 705,
Yeah.
for mine I tried my best, but my 0.7 is in the middle
Yeah.
of the histogram.
So
Does that
you use this code here, right? The first set of code, or did you just go into the menus and tell it to start here and do that kind of stuff?
Yeah, actually, sorry for on my part. I did not even know we had that code existed. I wrote all by myself.
Oh, yeah,
Most
yeah.
of it. Yeah, and that's how mine is. So what I did, what you showed in the class last time, I used the SD plot. So it looks similar to what you have, and then bin start, bin width, count, and y-axis grid. So all that's what I used.
Yeah. I mean, it's fine. They're both fine. One just, I think, looks a little bit better than the other. Let's see, that should be good. So if we run this one, so here's the first one, and then here's the second one, right?
So this is exactly what mine looked like.
Yeah, and that's fine.
Okay.
Because they're doing slightly different things. That you can see that they're making the bins differently. So you can see that this bar is basically centered at 0.7, whereas this
That
bar
one's-
starts at 0.705. So it's just it's a quirk of the way that these things work. That you could futz around with these and see if you could get it better. Like, I think, let's try this. Let me just for shits and giggles, let's see what this does. Yeah, it's not any better because then it gives me this thing. There's something about this that it just, I don't know why it's different. I honestly don't know
What it's doing, and actually, at least that's my understanding. What it is doing is it is taking 0.25 or something on the left and right. So bin is always in the middle. So this 0.705. So I tried like changing all the variables. For some
Oh,
reason,
okay.
yeah, it is doing it in the middle. So this 0.705 is in the middle, and then there is equal like width on the left and right. That's how it is doing. So I think
Okay,
it
let me
is.
try that then. Let me see if 68 does it then. Hey, there you go.
Yeah.
That looks a lot better. That looks basically exactly like ours. It just has this one little extra empty bin here. So yeah, you're right. That's exactly what it's doing is it's basically shifted over by that 2.5% or 0.025 because it's centering. So that is the big difference. That's what I thought I was seeing from the two is that with this one, the endpoint says that is specifically where I want the first bar to start. With bin start, it says that that is the middle of the first bin, and then this is how wide it is. So that's why if you tell it to start at 0.705, it's going to look different than this one because this one started at 0.705. Because this is 2.5, if you take off 2.5%, which takes it down to 68, that's why you get the right thing. And in fact, let's try going up by 2.5. Let's try. So that'd be 3. Let's try 73. Let's see if that gets rid of that that one empty one to the left. There we go.
Uh-huh.
I can outthink technology. So that's how you could make yours look exactly like mine, but it's not necessary, right? You don't have to make it look just like mine.
Okay, because I'm almost done with my
Yeah, no, you're
assignment.
fine. You're fine. You're fine. I just like to point these things out because
Yeah.
sometimes there's people in the class who like to play around with the code and kind of learn stuff as they go. But hopefully what you've learned is go to this document, right? All the code is in this document. For everything we have to do in this class that involves coding, all of the code is in this document. So you don't have to recreate the wheel, so to speak. And that's in our Google Drive. It's been there since day one.
Yeah, I miss seeing that. So thank
Yep.
you
Yep. No
for
problem.
showing that today.
Of course. Yeah. What else, peoples?
Dr. McBride, this is Christina. I have a question on D. I've just been like fascinated with the differences between Excel and SAS, and I'm a novice SAS person, and I don't know why I'm enjoying this so much. My family wants to kill me,
Sure.
but on D, the question around the chart that's the most informative for taxpayers. That's a categorical variable, right? I mean, you're just trying to understand like the percentage of spend.
So wait, sorry, stop. D. Oh, this one for number 1.
Yeah.
Which of the 4 charts is most informative? Okay. Go
Yeah.
ahead.
I mean, you're looking at, I mean, so my guess on it is that the pie chart that organized the program by category and percentage of spend was probably most informative because that's how I vote. I look at that type of stuff.
Yeah.
But is there a wrong answer there?
No, not as long as you justify it.
Okay.
Yeah, any of the questions that seem to be opinion based are never going to be marked wrong as long as you just give a reason.
Okay.
And that goes for mini projects and final projects as well. I know there's some questions floating around in there that they're pretty subjective. They're basically asking you for your opinion.
Yeah.
As long as you justify it, you're fine.
Okay. Thanks.
Yep. Vandana?
So 3.4D, is that like both, to me, both parts seems like the same. That what is the probability of greater than 0.9 ppm, and predict what proportion of days in the coming will have greater than. So is it the same question?
Well, no, because if the probability was 50%, then what proportion of days in the coming year? Yeah, you're right. Yeah, that is the same question. I thought they said what number of days. So
Okay.
yeah, you're absolutely right. It's pretty much asking the exact same question. I don't know why they're asking it twice, but yeah, proportion and probability are the same thing. It's usually proportion is usually written as a fraction, whereas probability is usually listed as a decimal or percent. But they're the same darn thing, right? Because 1/2 is the same thing as 0.5, which is the same thing as 50%. That's not the answer, but I'm just saying if it was, proportionally would be 1/2, and then probability would be 0.5 or 50%. Yeah. So just, yeah, calculate it and list it in any of those. You can list it as a fraction, you can list it as a decimal, you can list it as a percent, doesn't matter. I'll take all three.
And I'm sorry, I am in our Google Drive. Where do I see the code? Is it SAS stuff? The
If
code file.
if you're in our Google Drive, it's in SAS stuff. It says Math 807 SAS How-To Guide. So third file
Got
down.
it. Okay. Thank you.
Yep.
And then I have one question about the 3.10.
Yep.
So we are supposed to draw 3 different histogram for each year.
Correct.
Should they be in the side-by-side panel, or they can be like top
No,
and
no, you can do
bottom?
them individually and just copy and paste them individually into your Word document. Yeah. There is a way to make SAS do all three of them at the same time, but you don't have to do that. Just make sure you generate one for each year and then copy and paste them all into your Word document. They don't have to be in the same panel at all.
Can I ask a question on that one, Dr. McBride?
Go for it, Christina.
So when I looked at that, and I actually did figure out in SAS how to get them all to plot, because I can't stop looking at all these different, I mean, you can find anything you want on SAS on the internet. That's what I
Totally.
learned.
Yeah.
But I mean, they really haven't changed much over the 17 years. Like, I mean,
I agree.
The distributions are all skewed left, correct?
Correct.
So they really haven't changed much over the last, and so I just wanted, I mean, I didn't think that was a trick question, but they don't look like they've changed at all.
No, and I think I've said this before, a no change is the same thing as basically getting, when you get, finding no difference is just as significant as finding a difference, right? I mean, it's still a result. So when they say what major differences exist, I mean, you could legitimately say none, really. Because I'm even looking at their modal class, and the first two I think are both like sitting above 70, and the last one I think is sitting above like 72. So even their modal classes, like the, so when you graph it, there'll be a peak. They're definitely skewed to the left, but where the peak is almost identical on all of them as well. So I mean, I guess you could argue that the one major difference is one of the years modal class is 72 and the rest are 70, but again, with those types of questions, just point out stuff. I mean, you're totally fine with saying, well, there really aren't any major differences. They're all skewed to the left and they all have roughly the same shape. Okay, that sounds fine. Why do you think the plots have changed over these 17 years? Well, they haven't changed much, but you would imagine there'd be some sort of influence from something, based from the, what it's all about. And then how could Congress use the information on these plots for writing tax laws, allow major tax deductions for homeownership? Really, if it was up to me, I would just get rid of these. They're stupid questions. This is not a political science class. It's just a statistics class. So go ahead and answer it. Think about it. But in all honesty, I don't even look at either one of those. I don't grade them.
Yeah, I think I overthought that one.
Yeah.
Because what I looked at is how the data has changed over the years. Like we have now more number of states which fall into the 65 to 75% category. So
Sure. That's totally legitimate. Absolutely. Yeah, you could talk about how percentiles have changed, like how many states were, above a certain point versus how many are now above that same point, those types of things. Sure, absolutely. I guess what they're trying to get you to do with these types of questions is kind of put yourself in the footsteps of somebody who would be running this analysis, and then ask yourself, so what? Why would I run this? What would I care about? What would be the things I'd want to look at? How could this data help me? You know, those kinds of things. So it's trying to get you to think about things from a researcher's standpoint. What else?
So when we did, when we computed mode, yeah, it's in 3.24.
Yeah,
SAS only gives one mode.
yeah, correct. It only gives you the lowest mode unless you use the code in this lovely little document that you've now discovered. There is, where is it? Here it is. This is the code that will give you all of the modes.
Okay, got it. Because I just put it in the notes that SAS gives this answer, but actual mode values are this and this.
Yeah, yeah. And it's the same with Excel. If you do equals mode in Excel, you'll only get one mode. But if you do equals moti, right, it returns a vertical array of the most frequently occurring or repetitive values in the array. So mode.multi will actually will show you if you have multiple modes. So that's how you get it out of Excel. Because if you use just the mode function, it doesn't work. It'll just default to the smallest mode, which is what SAS does, right? So like if you have a mode of 15 and a mode of 22, it's just going to report 15. Whereas if you do the mode.multi, it will tell you both 15 and 22 are modes. Anything else? If you guys haven't gotten to it yet, to describe a method by which the mean for the combined data sets could be obtained from the 5 individual means. So what this question is trying to say is, okay, so what they want you to do is first compute the mean expenditures separately for each of the 5 groups. So you're going to have 5 means. You're going to have a mean of the first 2 rows of data, right? A mean for the second 2 rows, and so on and so forth. So each of these groups will have their own average. Then you go back and you run the average or the mean for the entire set. So you basically take away the grouping variables and you just let, all 57 or however many pieces of data there are, you take the average of all of those. And that's for part B. Then part C says, describe a method by which you could find the answer for part B if all you had were the 5 means from part A and their sample sizes, obviously. Because basically all you're doing is you're doing what's called a weighted mean, right? And the idea is if you have, so you've got 5 groups, right? Group A, B, C, D, and E. And this is their mean and this is their sample size, right? So it's a mean of 3 and there was 2 of them. This is a mean of 5 and there was 3 of them. This is a mean of 10 and there was 4 of them. A mean of 6 and there was 3 of them. Let's say a mean of 4 and there was 5 of them, right? So to find a weighted mean, first you have to figure out what's your total. So here's 5, 10, 14, 15, 16, 17. We don't want that. Let's make this 6, just so it's even 20. Yep, 5, 10, 20. Perfect. All right. So my grand, right, I've got 20 total pieces of data. What you have to do is you take each mean and you multiply it by its sample size. 5 times 3 is 15, 10 times 4 is 40, 6 times 6 is 36, and 4 times 5 is 20. Then you add all those together, right? So 6, 12, 17, carry the 1, 2, 6, 7, 8, 9, 10, 11, 117. So that's 117. That would be the total of all of my data values. Because if my average was 3 amongst these 2 data values, then if I take 3 times 2, that means they added up to 6, right? Because to get an average, it's literally you add everything up and you divide by how many things. 6 divided by 2 is 3. 15 divided by 3 is 5. 40 divided by 4 is 10, right? So these are the sums of each of these groups. You sum up all the sums, and this is the grand total. And if you take the grand total and divide by how many things you have, that gives you the mean for the entire group. That's called a weighted mean, because you're taking the mean of each group and you're weighting it by multiplying it by its sample size, right? You can't just take the means and add the means all together and divide by 5, because they have different weights, right? There were only 2 of these, there were 3 of these, there were 4 of these, there were 6 of these, there were 5. So they're not evenly weighted. If these were all the same, right? If these all had 3 or all had 4 or all had 5 or whatever, like the sample sizes were all the same, then yeah, you could just average the averages because they were already evenly weighted. But these aren't, so you have to do a weighted mean. And that's what they're asking you to describe and think about with that thing. That's pretty much.
Brian, can you go back to that the display that you just wrote out? I was following it and I had one little part. Okay. Yeah, all I need is 5 seconds. Done. Okay, I'm good.
Okay. Anything else from the homework, guys? I think we've kind of gone over most all of it.
I have a question that I think is for week 3 that's kind of related, I think, to the weighted mean, and it has to do with the standard deviation. And I was trying to follow it from the book to try to.
Yeah, they have the exact same question, but they do it for standard deviations.
The only question I had on that was in the book. I thought, with a weighted mean, you divide it by the total number of observations. In the book, they recommend subtracting the observations by 1 so that your standard deviation is higher, so you don't underreport the standard deviation. Is that correct?
Well,
Okay.
yes, that's the difference between a standard deviation of a population and a standard deviation of a sample. We always do -1 because standard deviation is a biased measure and it always overestimates. So, always underestimates. So that's why you take your sample size and subtract 1 from it, which makes it smaller, which makes the standard deviation bigger. And that's just a quirk of the way you compute standard deviations. Is the sample standard deviation will always systematically underestimate the true population standard deviation. So that's why we adjust the formula by n-1, which makes the standard deviation of our sample a little bit bigger, which makes it more closely representative of what the population standard deviation would be. But as far as question C is concerned, there is really no easy way to calculate a standard deviation of an entire set of things from the standard deviations from the subsets, right? So you're going to have, just like before, of having the means of all of these. Instead, now you have a standard deviation of each of the 5 groups. If you were to take those 5 standard deviations and manipulate them to try and do like a weighted mean version or a weighted standard deviation version to come up with what the standard deviation of the whole set of all the data is, it's not going to be close. So I honestly don't know what they're trying to get at with that question. I've been thinking about this for years that I've been teaching these classes. Why? What are these students supposed to learn from this? And the only thing I can think of is that they're trying to get you to realize that the standard deviation is not the mean. I don't know, that the 2 things are computed differently. And because of the fact that a mean is an unbiased estimator, we can do a weighted mean and everything is fine. But because standard deviations are what's called a biased estimator, we can't really do a weighted standard deviation and expect to get an accurate result. But by asking you to describe a method by which you could do it, when in reality there is no method that can do it, to me that seems like a really bass-ackwards way to try and teach you that standard deviations are different from means. So I don't get it. I really don't.
So probably what I did was wrong, I'm sure. But when I did it, so I took the standard deviations from each individual group, multiplied it by the number of observations, like same thing that you would do with a weighted mean.
Yeah,
and then divided it by the number of observations minus 1, I came up with a standard deviation of 35.9042.
okay,
But the standard deviation from the combined set is like 35.4243. So it's not like, it's higher, right? But
Right.
it's not like,
yeah, it's
I
not
didn't-
terrible. Yeah,
yeah, I didn't know. I mean, I was guessing at it because I've never seen a question like that before. I knew what to do with a weighted mean, but that was one that threw me off. So
yeah, no, I think that's really good. That's very close. I think you could also try, instead of multiplying each standard deviation by its sample, multiply it by its sample size minus 1.
oh, I see.
And
then divide. I
and
see.
then-
Okay.
And then still divide by the 83 minus 1. So I think there's 83 total. So
Yep.
still divide by 82 and see what you get with that. That might even get you something closer.
Okay. I'm gonna try that.
Yeah. Anything else from anything? Week 2 homework, week 3 homework, mini projects, whatever you got.
Hey, Dr. McBride, this is Madrid. The only thing that I wanted to ask about, I know you looked at changing the class time. I missed the first couple of minutes. I couldn't get my internet right. But did we talk about that at all tonight?
Did we? Or can we?
Well, I think I missed like 2 minutes. Like I think I came in at 6:02. So
Oh,
I
yeah,
didn't
no.
know if you all.
No, we
in
hadn't
the
talked
first
about
two.
it. I had already sent out the email and I said that we're going to meet this Sunday. So we're going to meet this Sunday at 7 p.m. Eastern time because we're meeting next week on a Wednesday because of Thanksgiving. So instead of
Okay.
doing Monday, Wednesday, and basically meeting just 2 days apart, I thought it'd be better to back the Monday up to Sunday and get
Okay.
started on week 3 a little early, hopefully, and then do Sunday, Wednesday.
All right.
So I put it on the calendar. So your Canvas calendar should show that the meeting is Sunday at
All right.
7 and Wednesday at 7.
Okay, yeah, I got the changes. I didn't know if we were going to discuss it or, I mean, if that was just a done deal or what. So I really got to make some adjustments.
Yep, sorry about that, but yeah, I'm trying to accommodate everybody, and there were so many complaints about the Monday night meetings that I thought I'll try a Sunday night, and then maybe people will shut up, but we'll see.
Okay.
But what you said that for this assignment, we can still submit it tomorrow for your feedback, but next week, because of the Thanksgiving,
Yeah,
we don't, yeah, okay.
correct. Yep. Christina, you still have another one?
I do. And this is actually in week 3 as well. So question 369, where it's talking through the process of like a scatter plot and then correlation.
Yeah.
I just have a question and so for the correlation analysis, I know how to create the coefficient of correlation. I know how to do that with SAS, but it doesn't give a p-value when you do that. The only way that I've been able to get a p-value is if I actually run like a linear regression,
Right,
and then it'll give you a p-value.
right.
But for you to really make a determination of the correlation, you need to know the p-value, right? Like, so when you run the correlation coefficient analysis, it just gives you like that little grid, right? And
Right.
it'll say the Pearson coefficient is the
Yeah.
n number. It doesn't give you the p-value.
Correct.
Is there a
Yeah.
way to get it to come up in there? So that, I mean, I ran a linear regression and pulled the p-value, and that comes up right in your regression. It comes right up in your graph and you do that. I just didn't know if there was a way that you could pull it into that table without having to actually run a regression.
There's no way that I know of.
Okay.
That correlation, menu operation, whatever you want to call it. Yeah, all it does is just give you the very simple R value. It just
Okay.
gives you that. And I don't know of any way to get the p-value. There are tables out on the internet where if you know your sample size, you can look it up and then it'll tell you whether or not your Pearson correlation, your R, whether or not it's significant based on your sample size. But I think it's just easiest to run the linear regression like you did to get a p-value that way. Now, as far as this question is concerned, you don't technically need to run the p-value to answer any of these. Because, it just says compute the correlation between them.
Yeah.
Right. So that you get that from that one table. Construct a scatter plot. Okay, that's easy. Does the value of the correlation coefficient reflect the degree of association shown in the scatter plot? That's basically just saying, does the shape of the scatter plot seem to match the R value that you get? And then why do you think there may be a correlation between these two diseases? That's just, basically talking about, why you think these two things would or would not be related. So they really you don't have to worry about the p-value for any of those. We in fact do the p-value analysis, I want to say in the final project. It comes up somewhere, I can't remember where, but there is later on down the road where we have to run a scatter plot analysis, and we have to get a correlation and a p-value, which means we have to run it with the linear regression option. And I thought there was a way in the linear regression option, I think somewhere in the menu structure, you tick on something and it'll spit out the scatter plot as well. So you can basically get everything from just running that one analysis.
It does, and that's what I did. And I work in healthcare, so we live by p-values on everything.
Yeah. No, it's a good thing to do, because I mean, p-value is the strongest indicator of what we call statistical significance. So yes, I wish more people would live by the p-value, especially people in what I call the soft sciences, people in sociology, psychology, things like that, education, that are reporting statistics, and they never include what the p-value is. And it's just like, God damn it, how do I know, how significant these results really are without a p-value? Or they won't give you any kind of measure of significance other than just that, here's my results. Okay, yeah, but was it significant? Right. So yeah, people need to spend more attention to that for sure. What else? Any others?
I've monopolized all the time, so I'm going to hold my mini project questions till next week.
Yeah, I would suggest just asking them. You can even ask them Sunday, after I'm done lecturing, if there are any questions. Because really, in all honesty, everybody should be started on the mini project by now, because it's due, the end of next week. And I don't think a lot of people want to be working on stuff over the Thanksgiving holiday. So it would behoove everybody to get going on that mini project now. So, I mean, I would say feel free to hold off, but if nobody else has any other questions, we might as well ask them now, because we've still got 13 minutes. So does anybody else have any other questions before we let Christina monopolize everything?
I was going to tell Christina, go ahead with it, because much of what you guys are talking about is helping me, but I'm scrambling with just trying to put all of this together.
Yeah. That's what I keep telling students. I'm like, don't ever feel like you're monopolizing the conversation, because I guarantee you there's other people that have the same exact questions, or will have the exact same questions later. They just might not be there. So there's no such thing as monopolizing the conversation. It's just the person.
So Christina, your question is helping, because you're thinking of things that I haven't even crossed yet. So it's helping me get to that, at least get to the point that you are.
Yeah.
Well, if it makes you feel any better, I've had some time on my hands because I've been quarantined with COVID. I'm finally out of quarantine, so I haven't been able to go to work. I've been working from home.
Yeah. See, you're one of those good people who, when you get quarantined, you actually do things. I get quarantined, and all I do is put on 20 pounds.
You're giving us a head start.
Yeah.
Thinking about the mini project. Go ahead, Christina.
All right. So go ahead, Christina. What are your questions?
Okay, let me, I have like 5 documents open here because I had week 2. What did I have a question on? Hang on a second.
Yep.
I got to find it. I had everything marked that I wanted to ask, and then I didn't want to be like what I'm doing right now, which is being a question hog.
Mini project.
Oh, actually one thing I did want to tell you, I did figure out what I was really struggling with the Pareto chart, which was to organize, and I thank you for pointing that out, that it was in the actual code, or like in the directions, because I skipped right over that and like found some really complicated code that some data scientists have on the internet, and I could not get it to work. But I've also found that there's like a very nice Pareto chart that you can actually get right out of Excel. Actually, to tell you the truth, some of the graphics in Excel are better, I think, and you can customize them a little better.
Oh, I agree. As far as graphics are concerned, Excel is far and away better than SAS. It's easier to run. You can customize them better. You can put in colors and you can, title them, and all that is so much easier. So yeah, running any kind of graphics is always better in Excel. Absolutely. 100% agree.
Okay, I know what I wanted to ask you. So the box plot of the blood pressures, I understand how to run the side-by-side box plot.
Okay.
And I know in the mini assignment, you're going to want us to discuss the finding, right? I mean, you don't just want to see that we were able to run the exercise. You want us to interpret it, obviously.
Correct.
So on the box plots, like I don't know why I cannot get myself oriented on. We use these at work too, and I just can't for whatever reason. But I mean, what's the best way to interpret the box plot? Like, what is it? I just want to like hear just a general take on it, like how I should be thinking about the box plot in terms of interpreting the data.
Box plots are a visual representation of the 5-number summary. So when you have a box plot, so here's a typical box plot. Box plots, by the way, should always be horizontal. Vertical box plots make the hair on the back of my neck stand up. The reason why box plots should be horizontal is because they represent numbers on the number line. So they should be horizontal, just like the number line. Because what the box plot represents is the 5-number summary, where you have minimum, Q1, Q2, or what is the median, Q3, and max. That's a standard box plot. If it's a modified box plot, then you end up possibly getting outliers on one or both sides of the whiskers. And then instead of this being the absolute minimum and the absolute maximum data values in your data set, it's the minimum value that is not an outlier and the maximum value that is not an outlier. But the rest of the box is always the same. This is still Q1, Q2, and Q3. Now, if you don't know what Q1 is, that's the 25th percentile. So 25% of your data is equal to or less than whatever that value is. Q3, obviously 3 quartiles, right? That's 75%. And then the median, we all know, is 50%. So that's what a box plot tells us, is it basically gives us percentiles. It's a visual representation of how our data is spread out. It's really a measure of spread, because if your box is really small, right? If you got a little tiny little box and big ass whiskers, then you know that you've got a real small spread here for this, is because this is 50% of your data, right? 25 to 75. And then big whiskers means you've got outliers, because if you did a regular one, right, it would go all the way to min to the max. If you did a modified one, it would probably stop here and here. So it just kind of tells you how spread out your data is, or how clumped together it is. So that's what a box plot is. That's what a box plot does.
Okay, got it. And so so the whiskers don't necessarily go out to your very last data value.
They do if you're running a regular box plot, not if you're running a modified box plot.
Okay.
I
okay.
believe in SAS, it automatically does it as modified.
It does.
Yeah, because I believe when you run it, it shows outliers as little asterisks.
Okay.
Yeah, and so those whiskers are stopping at the largest and smallest data values that are not considered outliers. And I think we all know what an outlier is. It's just something that is largely different than the majority of your data, right? It's a lot larger than everything, or it's a lot smaller than everything else. And how we calculate that as far as a box plot is concerned is actually quite simple. So let's say we're making our box plot and our Q1 is 40 and our Q2 is 50, and maybe the median is up here at like 57. So this is Q1, right? This is Q3. Then we have something called IQR, which is the interquartile range, which is literally just Q3 minus Q1, or in this case, 50 minus 40 equals 10. It's literally the width of the box, right? The box goes from 40 to 50. That's a width of 10. IQR tells you how wide your box is. Then to determine where your outliers are, or what the cutoffs are for anything that would be considered an outlier, you have mild outliers that are more than 1.5 times the IQR away from the box. And you have extreme outliers, those that drink Mountain Dew, that are 3 IQRs away from it. So 1.5 times IQR is 15. Of course, 3 times it is 30. So what you do is you take those as distances, right? So I'll do this one in green. So you go down 15 from 40 and you get a cutoff of 25. Any data value that's smaller than 25 will be considered a mild outlier. If we go 30 down from it, right, that takes us all the way to 10. Anything below 10 is considered an extreme outlier. And then, of course, if we do the same thing in the other direction, right, go 15 up from the top, then we have a cutoff of 65. And this is where we get mild outliers. And then if we go 30 above the top, right, and go all the way up to 80, then anything beyond 80 is an extreme outlier. And then what will happen is your whiskers will stop wherever your data stops at this value or less. So like if you had a data value of 63, it would stop at 63. If you had a data value of 65, it would actually stop right at 65. If you had a data value of 63 and 67, it would stop here at 63. And then of course, 67 would be out here. So the whiskers just stop at the smallest data value that is 25 or greater, and in this case, 65 or less. And of course, these numbers are going to change depending on what your data is. But that's how it works. That's how they calculate the outliers for the displays when they do modified box plots. It's all based on the IQR, because the idea is this is 50% of my data. So 50% of my data is within 10 data points of itself, right? We can think of this as just points, right? Like maybe this is a score on a test. So 50% of my data is within 10 points. So if something is more than 15 points away from that, that's not playing nicely with the rest of the kids, right? That's totally different than everything else. So that's why it's considered an outlier. And if it's 3 times away from it, you're like, holy crap, that's way out there, right? So that's a real extreme outlier.
So for the box plot comparison, do you want us to discuss like interquartile ranges? I mean, I understand all of that. So is that what you're looking for in terms of like just comments? I mean, because this is.
You could discuss the interquartile range. I would think about it more from a layperson's standpoint, right? That, what does it tell me? It tells me kind of how things are spread out and where things are centered, right? If I had 2 box plots like this. So here's so if I had a box plot that looked like this, and then I had another box plot that looked like this, I would, and here's the median, I'd say, well, my 2 data sets have, roughly the same center, right? They both, their medians are close. They both seem fairly symmetrical. The only difference is the top one has a larger standard deviation. It's more spread out, right? Okay, so if I had 2 box plots that look like this, I'd say, well, those 2 distributions have pretty much the same spread, right? They're pretty much the same width. So they have roughly similar standard deviations, but obviously, group A is shifted to the right, meaning that group A has consistently higher measurements than group B, because everything is shifted. It's not just the mean is shifted, it's not just the median is shifted, but the whole damn thing is shifted to the right, which means it's just everything in that sample set is consistently larger than the others. Good night, Madri. And then the combination of things. Something could be shifted and have a smaller distribution. Something could look like this, where you've got skewed data, right? It's obviously skewed because you've got a much longer tail on this side than this side. So it's things like that you could comment on.
I got it. I will say that being in healthcare, when I ran the box plot, that would be a very highly effective blood pressure medication.
Yes, it would. Yes, it was quite a substantial difference. Yes,
very
absolutely.
substantial difference. Yeah.
Yeah.
Thank you very much for walking me through that.
Absolutely. All right, guys, that's 5 o'clock. Thanks for showing up. Enjoy the rest of your evening, and hopefully I can see most of you on Sunday. If not, remember, everything is recorded, so you can always watch the recording of both that and all the previous ones.
Thank you. Good night.
Yep.
Thank you.
Good night, everybody.